The strangest thing in our world is how anything exists at all. From the fiery heart of our sun to the solid ground beneath our feet. This calm reality we know wasn't born from peace. It was forged in chaos. So how did this chaos become our home? Our journey begins billions of years ago, long before any star shone in our corner of the galaxy. It started in darkness within a vast cold molecular cloud. Imagine a cosmic ocean spanning light years filled with the raw ingredients of existence. This primordial cloud was primarily hydrogen and helium, the basic elements forged in the Big Bang. But it wasn't pristine. Over countless eons, dying superheavy stars had enriched it, seeding it with heavier elements like carbon, oxygen, and iron. These were the precious cosmic dust forged in stellar furnaces scattered into space. Within this silent, vast expanse, a single, relentless force was at play: gravity. Imperceptibly at first, tiny clumps of dust and gas began to draw closer. Over millions of years, these whispers of attraction grew stronger, pulling more and more material into denser pockets. This wasn't a sudden event, but a slow, patient cosmic dance. And within one such pocket, a destiny was forming. The destiny of our sun and everything that would later orbit it. Indeed, newborn stars are often found dazzling within brilliant, colorful nebulae. But the true story of star formation, including our own sun, begins much earlier in the heart of vast, dark, dense clouds. Within these vast, dark clouds, gravity relentlessly collapses thousands of individual dense clumps. Each clump is destined to become a potential star, a new beacon of light. The core of a massive dense clump compresses and heats dramatically until it forms what we call a protostar, a star in its embryonic stage, glowing faintly from the energy of its collapse. A protostar continues to grow as a disk of gas and dust accretes onto it. This disk is crucial. Some of the material is violently ejected along twin opposing jets from the poles, clearing the surrounding space. But the true magic begins as the star finishes its formation. Deep within its core, nuclear fusion ignites, turning hydrogen into helium and unleashing an immense amount of energy. Our sun is born, radiating light and heat for the first time. While the star achieves stability, planets are building up within the surrounding disk. A few 100 million years later, a new solar system has assembled. This incredible process of stars and planets forming together happens in billions of sites across our galaxy. It's a universal blueprint for creation. With our young sun now shining brightly at the center, the stage was set for the next act, the birth of the planets themselves. Surrounding the sun was a vast spinning disk of leftover gas and dust, our very own planet factory. Within this swirling disk, chaos met order. Tiny dust grains, some no bigger than a speck of smoke, began to gently collide and stick together. Over millions of years, these microscopic fragments grew first into pebble-sized clumps, then into icy rocky spheres a few centimeters across. This process, known as accretion, transformed dust into boulders, and boulders into planetesimals, kilometer-sized building blocks, each on its own collision course. These were the true seeds of the planets, swirling in a cosmic ballet of destruction and creation. But not all parts of our planet factory were created equal. A crucial boundary existed, the frost line. Closer to our young sun, intense heat evaporated all but the most resilient rocks and metals. Here, water and other volatile compounds existed only as vapor. This meant that within the frost line, planetesimals were primarily made of dense rock and metal. But beyond this line, temperatures plunged, allowing ice to solidify. Water ice, methane ice, ammonia ice. Suddenly, the available building material became abundant, allowing for much larger planetesimals to form at a much faster rate. The stage was now set for the final violent phase of planet formation. The seeds were sown, and the cosmic game of gravitational billiards was about to begin. And the most dramatic of all these events was a collision that would shape our world's destiny. For decades, we thought we knew the story of our moon's birth, a story of slow, patient creation. But what you are seeing now is a fresh take on that origin story. A supercomputer simulation so detailed, it's changing everything we thought we knew. This simulation suggests that the moon may have formed in just a few hours. It is one of the highest resolution simulations of the moon's formation ever run. The simulation starts, as the theory suggests, with the collision of a Mars-sized body with our planet. But what happens next is radically different. Instead of a slowly forming ring, the debris from the impact immediately coalesces into two main bodies. The smaller of these two bodies will become the moon. In a stunning cosmic dance, the gravity of the larger body propels the smaller one forward, launching it onto the wide and stable orbit we see today. This new vision opens up incredible possibilities and will help us to finally understand the intertwined history of Earth and its constant companion, the Moon. Beyond the crucible of fire where the rocky planets were forged, a different kind of creation was taking place. Out here, beyond the frost line, an abundance of ice allowed planetary cores to grow much larger, much faster, giving birth to the titans of our solar system. First among them, Jupiter, the undisputed king. Its massive core, 10 times the mass of Earth, allowed it to capture a colossal atmosphere of hydrogen and helium, growing so large it now outweighs all other planets combined. This gas giant is a world of violent storms and swirling clouds dominated by the Great Red Spot, a hurricane larger than our entire planet. Jupiter's immense gravity became the solar system's guardian, shaping the orbits of its neighbors and protecting the inner worlds from ancient impacts. Next in line is Saturn, the jewel of the solar system. While also a gas giant, Saturn is famous for its breathtaking system of rings. These magnificent structures stretching thousands of kilometers wide, but in some places only meters thick, are believed to be the shattered remnants of a moon or comet that strayed too close. They are a beautiful icy fossil from the chaotic early days of the solar system. Further out lie the ice giants Uranus and Neptune. These distant blue worlds are different. Their cores were unable to capture as much gas, leaving them with atmospheres rich in water, methane, and ammonia ices, which give them their distinct colors. They are the silent frozen guardians of the solar system's edge worlds of mystery we have only just begun to explore. And so from a single chaotic disk, two entirely different families of planet. After hundreds of millions of years of violent creation and cosmic chaos, a sense of order finally emerged. From a single vast cloud of dust and gas, a star was born and two distinct families of planets found their place around it. The solar system, as we know it, had finally settled into a stable, predictable dance. In all this vastness, among fiery worlds and frozen giants, one planet became truly special, not because of its size or its rings, but because of a delicate combination of factors: the right distance from its star, a protective atmosphere, and the presence of liquid water. On this small rocky world, a new story was just beginning, the story of life. Our existence is a direct consequence of this cosmic history. The iron in our blood, the calcium in our bones, all forged in the hearts of stars that died long ago. We are, in the most literal sense, the children of the cosmos, a way for the universe to know itself. And it makes you wonder, with billions of other stars in our galaxy, each potentially hosting its own family of planets, how many other stories like ours are currently unfolding in the silent darkness.